Good morning, students. In last class, while doing the revision of P, that is inverse transform, we have solved the sums based on standard formulas, and then by completing the square, and the next part we will be learning here now. I will write unit 3 in revisions remaining part we will be doing here, and in that so while preparing for PUC CET exam and other competitive exams, we have studied the method of partial fraction. In short, I will be telling. First one is, whenever suppose I take here s plus 5 divided by s plus 1, s minus 1 and s plus 3. In short, if this is denominator is linear, in that case we solve this as, the first step will be a divided by s plus 1 plus b divided by s minus 1, and for the third one c divided by s plus 3. Then assign different values for this s, based on that solve and get the answer for these constants a, b is equal to and c is equal to. Then while finding the inverse of the same, then you denominator plus here is the denominator, and similarly c. What I mean to say, look at the denominator, here it is linear. Suppose the same example I will take here. Suppose this is s plus 5 square. The difference is, here all the three brackets are different and they are linear, whereas bracket square. This is type 2, and after that solution same. Then the third one means non-factorizable bracket if we have. In that case, a upon s plus here, the second again working for a, b, c will be same. So that based on this concept, we will be solving few simple sums here. The example which I have chosen here, 2s minus 3 upon s minus 1, s minus 2 and s minus 3. Just now we have discussed about the nature of the denominator and the appropriate formula to be used. Splitting, how we have to be used that. So now here if you look at this, 2s minus 3 upon s minus 1, s minus 2, s minus 3, and this I will write it as a upon s minus 1 plus b upon s minus 2 and plus c upon s minus 3. So now we have to assign different values for s, so that we will get values for these constants a, b and c. Shortcut method is there. See how we are going to solve it is, suppose 2, 1. What will be the LHS? This will be minus 1. This will be minus 1. That is equal to, S is equal to 1 means this term is going to be 0. In that case, LCM will be taking here, B will be, even C is going to be 0. Then what will remain? 0. If you are not comfortable with it and solve it, no problem. The second one I'll go for, that is for S is equal to 2. S is equal to 2 means 4 minus 3. S is equal to 2 means this term I have concentrated, focused on this term. So obviously this is going to be 0, this is going to be 0. What remains is only B will remain here, and in that case B, then in bracket 2 I have taken, 2 minus 1 will become 1, and into, yes, only B will remain, also equal to 1. Here one thing on solving for S is equal to 1, here 2 terms are there, so that will be minus half, and for S is equal to 2 we get minus 1. S is equal to 3. 3 is 6 minus 3, that is 3 is equal to, so S is equal to 3, is going to be 0, only will remain C in bracket, this gives 3 by 2, so let me denote this by 1. L inverse of 2s minus 3 divided by s minus 1, s minus 2 and s minus 3 is equal to, look at this RHS part, that is a value, a how much we got? Minus half into L inverse minus 1. What about B? B is minus 1, so I'll write minus L of 1 divided by S minus, and what about C? It is 3 by 2 plus 3 by 2, so the third one S minus 3, so that this will be divided by S minus 1 e power t. T answer. So now the second example, just only I'll discuss the partial fraction part. 3s minus 1 upon s minus 3 and s square plus 4. This we have discussed just now. So this is non-factorizable. In that case, the splitting will be a upon s minus 3 plus bs plus c upon s square plus 4, and then solve for a, b, c. Then next one more. Better I give this answer. You can try this. Answer you will get at the end 18 by 13 e power 3t minus 8 by 13 cos 2t plus 15 by 26 sin 2t. Then little different sum it is s square plus 2s divided by s square plus 2s plus 2 and s square plus 2s. This is the example. So as it is in the partial fraction also it's difficult. So in that case, if you look at this, numerator and denominator contain two terms same. That is here s square degree is same. So what I can do here, I'll just replace this square plus 2s by t, so that it will get reduced to the simplest form. I can say that is t plus 3. Here this will be t plus 2 and the second one will be it is t plus 5. So that when you are going to split it or going to write it in the form of partial fraction, it will be a upon t plus 2 plus b upon t plus 5. Once take the value t is equal to minus 2, so that b will become 0, you can get value for a. And in the next step, substitute t is equal to minus 5, so that it will be 0 and you will get the value for b. Will get reduced to, and the final answer will be here by 3 sin t sin 2t. So these many sums, two sums, I think 2 to 3 sums we have discussed and one I have solved in detail. This is finding the inverse Laplace transform by the method of partial fraction. As I said, 3 types are there in this. Denominator where it is linear in nature. When it is linear in nature, all distinct different brackets they are. So in that case, the splitting will be a divided by first, b divided by second, c divided by third, and so on. Then depending on the value, required value, you substitute and get the value for the constants a, b, c and so on, and in last step apply inverse Laplace for each term separately and write the answer. Second one here, what we have, the example which I have chosen is here it is non-factorizable. In that case, the second splitting will be bs plus c divided by this. Again assign different values for s, and so that you can get values for a, b and c and so on, and right answer I have given, you solve it. Third one, look at the denominator and numerator. First two terms are identical. Here s square plus 2s, s square plus 2s, and here. So that we can replace this by some other parameter that I have taken as t. So that it is t plus 3, very simplest form it will get reduced to, and t plus 2, t plus 5. Again choose once t is equal to minus 2, solve it. T is equal to minus 5, again solve it, you will get the value for a and b, and the final answer will be this. Now coming for the next part in this. It is find the inverse of logarithmic and inverse functions. inverse transform of logarithm and inverse function. So on each I will be solving one example. The first one I have taken is, it is log of 1 plus 1 by s squared. So in PUC you might have studied the basic laws of logarithm. First one is last one is change of base and rarely will use. So let us three basic laws of logarithm because I am going to implement that here. First I will take LCM, in which form it gets reduced to second one, so that I can write this as log square plus 1. I can use the third one. Yes, I will write. So that now whatever this LHS we have written, that is f bar of s. Now I will go for differentiation. Based on those four properties only these examples we are solving. So f dash bar s is equal to, differentiate this. Minus sign is there, minus I will take in x, but s square plus 1 is there. So 1 upon s square plus 1 I will write into d by ds of s square, that is going to be 2s, and minus this 2 by s. So here minus 2 I can take common, so that is square plus 1 and minus 1 by s. Now finding L inverse of, that is minus f dash bar of s is equal to minus 2 into L inverse of s divided by s square plus 1 and minus 1 by s I will write. So that this is minus 2. Look at this, L inverse of s upon s square plus 1 is nothing but it is t, and minus 1 by s is nothing but it is 1. So that now L inverse of this is nothing. We are solving this for f of t. So therefore I will repeat this. Log of 1 plus 1 by s square. Here laws of are actually 4 are on these three for the time being. LCM is taken, so s square plus 1 divided by s square, log m divided by second one, so log m minus log, that form I have written, and the next one is then s square I have to differentiate, so log of s square plus 1 will be 2s s square plus 1, and here so 2 by s common, for t, and that is parameter of RHS. So here one sum I will be giving for this. log f minus what you have to do here again n is there, so splitting when you will do, you have to solve. Answer for this homework sum, answer will be f of t is equal to 1 by t square, means what? Twice we are going to differentiate this, 4, then it is e raised to minus 4t then it is t plus e raised to 4t again t and plus e raised to minus 4t and into 1 minus e raised to 4t and into it is 1. So you can simplify this. If you simplify, it is 1 by t square, then 4 I'll write as it is minus 4t. T if you take common, e raised to, no, it is going to remain same only. So e raised to minus 4t if I take common, it is t minus 1 plus e raised to 4t if I take common, then this will be t minus 1. This is the answer. Note down the answer so that you can try. So again I am telling inverse transform of logarithmic and inverse function. This example we have chosen based on which is from logarithm. Next one I will be going for inverse. Next one, now inverse function I will be taking, in that tan inverse 2 divided by s square. So what we do is, first we differentiate this, f dash bar of s, minus sign is there, is equal to minus sign, then it is, see its differentiation is 1 divided by 1 plus x square, it is like that. So here in that form, s to 4 into d by ds of 2 by s square, 2 is constant, 1 by s square, differentiation is minus 2 by s cube. So already this 1, 2 is there, minus s cube, so that these two minus sign will get cancelled. And here s square is in the taking LCM, and so that what answer, yes, 4 it will be plus 4. So now LHS will be TF of t. TF of t will be L inverse of 4s divided by s raised to 4 plus 4. Now this cannot be, means we can't find a directly inverse of that term. So some power 4 plus 4, I can write this as square plus 2 bracket square minus 4s square. So that here this is in the form of a plus b bracket square. If you simplify, here e square a plus b and a minus b. The same thing I will be writing here, plus 2, whereas the second bracket s square plus 2 and minus 2s. And the next one, the method is the numerator should be obtained by making use of these two brackets, either subtract or add. So what I do here, s square plus 2s plus 2, the same bracket I have written, minus s square and plus 2. If these two you will simplify, s square will get cancelled, 2 will get nothing but LHS. Therefore, is equal to, now look at the place by two brackets. The denominator s power 4 plus 4, I am going now we are supposed to find when you will divide, this bracket is going to get cancelled. What remains? Hope you remember the previous class we have discussed about completion of square. Complete square we have to make here of these two denominators, and then f bar of f of s minus a, it will get reduced to e raised to minus as into inverse of that we are going to find here. When we solve it, that is Tf of t, the simplified form I will be writing L inverse of 1 upon, the first one will be S minus 1 bracket square and plus 1, whereas the second one will be 1 upon S plus 1 bracket square and plus 1. So that, look at this, here in numerator constant term is there, s term is not there, so no need of adjusting any s minus 1, s plus 1 and so on. This point has to be very clear. Whenever the example will get reduced to in this form, and if numerator contains s, then only that adjustment is required. If not, then go ahead, proceed in the same way. We will get here e power t L inverse of, whereas power square plus 1. So that e power t, the standard formula, 1 divided by s square plus a square. A is 1 here. That will be 1 by a into sin t. What one here? Functions we have studied, it can be written in some hyperbolic standard formula. So LHS we can't forget. Tf of t is sin t, very standard hyperbolic formula. T will be e power t minus t divided by 2, whereas cos hyperbolic is e power t plus e power minus t divided. Look at that. Without much effort, it can be written in the form of 2 into sin hyperbolic t. But entire t is the answer. Hope you understood. Inverse function I have taken tan inverse of 2 divided by s square. First it's differentiation, minus into, and into d by ds of 2 divided by s square, that is minus 4 by s cube. LCM is taken, s power 4 is shifted to numerator, simplification gives this answer. Then LHS is nothing but TF of t, and inverse of this we are going to find. Looking at this, it will be difficult to find inverse in the given form. So first we consider the denominator, and this can be written as like this, which is in the form of a square minus b square. Splitting comes like this, and by making use of the obtained two brackets, by subtracting which and here, and LHS is TF of t, whereas the denominator by this adding separately answer. One example you can try based on this homework. Cot inverse of s plus a divided by b, and the answer should be e power minus at sin bt divided by t. So till now we have discussed properties called the sum that is computation of square, logarithm. Here single functions were there if you look at them, but how to solve when two functions are there? Product of means two terms are there, functions are there. That gives rise to the convolution theorem. Statement and proof I am not going to discuss here. Only you remember when two functions are there, the best way to solve is convolution theorem. So now here 2 to 3 notes are there that I am going to discuss. Hash g of t, star or hash you can say f of t. Commutative property holds good here. Second point in a note is convolution theorem can also be written as L inverse of f bar of s into g bar of s is equal to f of g of t. And the last one, very very important, f bar of s into g bar of s is u is equal to 0 t f of u is minus u du conclusion is either this form or in this form, both are. So now let me solve the example based on this. One upon s square into s plus 1 bracket square. See here, this cannot be solved by of square or by partial fraction. Very lengthy it will become, but by convolution theorem it will be very easy. I will square, if I am writing it t, nothing but L inverse of the square, and what is that? T. Second one, g bar of s is 1 divided by s plus 1 bracket square. T, that is L inverse of this can be L inverse of 1 by s square, and that is t e power minus t. Now we'll go for convolution theorem. Line convolution theorem. I'll write this as bracket square, that is equal to, here it is t. See, the first one I'll write as, means t is there, that I can write as u, into the second one e power, replacing t by t minus u, I'll write this as minus u du. So if you simplify this, of u, because du is there, possible simplest form I can say. The same step I'll be writing e power minus t integration u is equal to 0 to t, and the first one is tu minus u square into e power u du. Now this is in the standard form according to Euler rule. Euler rule, hope you remember. Inverse, this is logarithmic, this is algebraic, this is trigonometric, and this is exponential. In this standard form only the terms has to be written. So according to that it is correct. Now the best one integration formula which can be used is Bernoulli's generalized form of integration. According to that, first term we go on differentiating, second term we go on, term gives us a constant with alpha in between. I mean is e raised to u. Then when should come. E power u 0 to t. So now when we substitute the limit, I am going to substitute first t, so that it will be square minus 0. Second one is u is equal to 0. This is 1, but again 0 minus the second term here is t. I can write this term as, and when u is equal to 0 and e raised to 0 is 1, I'll write, and 1, so that e power minus t makes as positive t to so that simplification possible is the add this common here, or out of the is to t you can take common. I'll explain this example. As I told, when two functions will be given or the product will be given, we take the help of convolution theorem. So these are the note. I said in this first one, commutative property holds good. Second one, this convolution theorem can be written like this. And the third one, this can be written as u takes the value from 0 to t, f of u, g of t minus u, du, or it can be written as f of t minus u, g of u, du. In short, first term can be written as u, second as t minus u, or the first term can be written as t minus u, second term can be written as in terms of u. Then split the given function so that standard formula can be implemented for that. F bar of s is 1 by s square, answer t. G bar of s, the second half I have taken, that is 1 divided by s plus 1 bracket square, and s plus 1 bracket square is e power minus t. Inverse of this, that is t e power minus t. When we apply convolution theorem, first term, that t I have written as u, second one g of t minus u I have written, means what? E raised to minus sign is there, replace t by t minus u, t minus u. There t is there, so that is t minus u. Look at this, du is there, so e raised to minus t comes outside the integration sign. What remains? U into this and e raised to u. So that I have multiplied here, t into u is tu and minus u into u square, e power u. Now Bernoulli's integration is applied here. I said Bernoulli's generalized form of integration is what? Where the first term we go on differentiating, second term we go on integrating with alternate sign between till the first term gives us some constant value. Because this is common sense that derivative of constant will be 0, so next step after that it don't exist. So when you substitute the limit, this is the answer we get here. Many examples are there in convolution theorem. You refer different textbooks and try to solve. Then next to this is applying inverse to solve the differential equations. Applying the concept of transforms equation. So for that, this set of formulas are essential. L of y dash of t, the expansion is s into L of t minus it is y of 0. The same expansion proceeds for double derivative also. It is s square Ly of t minus sy of 0 and then minus y dash of 0. Third one, s cube minus s square Ly of t, sorry, s square Ly of 0 and minus. So we should know this formula to solve any differential equation which are solved by making use of inverse transform. So for that, this one example I have taken. Point should be noted, the expansion or the given example can be in the form of y or it can be in the form of x. Suppose it is given in the form of dx by dt. Here what I have given, that is dy by dt in that form. Suppose it dx by dt, then wherever y is there, that has to be replaced by x. So here one example I have taken, that is x double dash of t plus 9x is equal to cos 2t, and given is what? X of 0 is 1, initial value is given, and x of pi by 2, that is minus 1. Point should be noted that when you will observe this example, it is not in the standard form. Means directly as it is, we can't apply the formula, this set of formula. The reason is, after x double dash of t, x dash of t is absent. After that, direct x of t is there. So one value for the time being, we have to assume some value so that in the easiest way we can solve this example. Since x dash 0 means x dash of t, this here it is not given, so that value I can take as some constant. Now applying Laplace, the way of solving is, given differential equation, first you have to write it on both sides, then implement or use the given conditions there and write it in the standard, and at the last or at the end use the answer, that x of t or y of t, like that we will be getting. So when I apply t is equal to Laplace of cos 2t. Now we are going to make use of, see, x double dash of t is there, means that is second formula I have to apply here. I will write this as s square into x of t minus s, just I have replaced x here, s into x of 0 minus s dash of 0. Hope you are getting the second formula I have used, s square, L y of t is there, x of t, minus s y of 0 is there, x of 0, minus y dash of 0 is x dash of 0. Second term as it is, 9 L x of t is equal to Laplace of cos 2t is s divided by s square plus 2 square, that is 4. Now there two values are there, x dash of 0 is a, we have taken, so this is a, and x of 0 is 1. So make use of that, so that from these two I can take Lx of t common. So Lx of t, when I take common, s square, and then since this is 1, this will be minus s. Since this is a, minus RH s square plus 4, or s square plus 9 equal to 4. In the next step, this term I'll shift there. plus 4. Now LHS should be only Lx of t, rest all the terms, means this s square plus 9 I am going to shift it to RHS, so that this is a plus s or s plus a divided by s square plus 9, and the second is s upon s square plus 9 and it is s square plus 4. As I told, we are solving for x of t, so obviously now inverse of each and every term separately, so that the first one will be L inverse of s upon square plus 9. Second is a is constant, L inverse of 1 upon s square plus 9. Then here some terms we have to adjust here, so that I will write s minus s, shortcut it is s square plus 4 divided by the same term. Here if you forget, if you balance here, L inverse, so that the first one is what? Standard formula if you apply for this, this is cos 3t a, 1 divided by s square plus a square, so a is 3 here, 3t, and now this is 1 divided by 5 I will write, and then next L inverse of s into divided by square plus 9 into s square plus 4. This is the first one. Second, s into square plus 4 divided by s square plus 9. Just I have divided separately, that's it. So that the first will be taken common throughout, square plus 4 t, and for the next one this term will get cancelled and that will be cos 3t. So now we'll go for the conditions given, that is when pi by 2. Answer what we get here is, that is L minus 1. Why minus 1? Because here x of pi by 2, this I am going to use it. Minus 1 is equal to, now here apply this, by 3, 1 by 5 will remain, use the value is equal to, when you it is 12 by 5 anyhow, hence last the solution will be of t is equal to, look at that, after simplification what answer we are going to get, that I am telling, 1 by 2t dt and be the answer. I'll explain this example. This is given x double dash of t plus 9x is equal to cos 2t, and these are the conditions. Since we need here in formula x dash of 0, which is not given, so that we have taken as some constant value I have taken. This is the when we apply Laplace for each and every term, this is expansion. X double dash of t is there, so the second formula is used. This is the expansion, and in this step Lx of t is taken common, so s square plus 9. X of 0 is given as 1, so this is going to be minus s, and x dash of 0 we have assigned the value as a, so this is minus a and RHS. If you simplify, this is the answer. Then Lx of t, that s square plus 9, that we have taken here in denominator, then here divided separately. By making use of the denominator available, by subtracting, we can find the inverse easily, but the compensating term should be, that has to be balanced here by dividing it by 5. And this is the simplified form. Condition is when x of t, that is x of pi by 2 is minus 1. So minus 1 is equal to the values, when you will substitute, you will get the value a by 3 is equal to 4 by 5, or you can write a is equal to 12 by 5. Then x of t is equal to, after substitution, this is the final answer. Again on this, so many different sums are there, you can solve that. Now moving towards the application part, the last part of this unit, that I will be solving. One example I will be solving here. Question I will be writing based on applications. An alternating electromotive force E sin omega t is applied to an inductance L, capacitance C, in series. Then show by transform